are leading the excavation of a recently identified deposit in Marble Canyon, battling the icy wind and snow for the prospect of a new discovery.
So I have something to show you here that we collected the other day. It's a big slab.
Wow.
With this fossil here.
Wow.
Yeah, it's quite extraordinary, isn't it?
I've never seen anything like it.
That's the exciting part about the Burr Shell. There's always something new coming up.
These rocks contain some of the first evidence of multicellular organisms on our planet. The first eyes. The first hard body parts, bones, and exoskeletons. The first lateral symmetry. The first efficient guts. Even the first brains. Sculpted in the finely packed sediment of an ancient ocean is the turning point in the evolution of advanced life on Earth. The Cambrian explosion.
Very good.
A very nice slab with some dahlia on it.
Oh, wow. Wow, that's quite spectacular. So to put things into perspective, today we know life is widespread, it's all around us, in the oceans, in the mountains, and so on and so forth. And we can trace the root of all these life forms to pretty much the Cambrian period.
As far as we know, life dates back at least to 3.4 billion years ago. And it wasn't until about 540 million years ago that we have the Cambrian explosion. And that fundamentally changes the planet. It goes from a microbial world to one that is literally teeming with animals, and not just small and simple animals as we would have originally imagined, but instead we have a whole array of complex life, still only in Earth's oceans at that time, but all of the major groups of animals appear geologically instantaneously.
Among the species found here is one of the ancestral roots on the tree of intelligent life.
So one of the most important fossils that we find here in this area is Metaspregena. It's hard to pronounce, but it's actually a very, very important fossil for the understanding of our own group, the vertebrates. And this is an animal that looks like a fish. He has a pair of eyes at the front and a structure which we call a notochord, which part of it will eventually become our spine. And Metaspregena doesn't have any evidence of structures that could help him to protect itself. So I tend to think that perhaps he was smart. And the fact that we find them clustering, which shows evidence of schooling, is very much reminiscent to what we know in modern fish, who have evolved such behavior to avoid predation.
Predation is a very key factor in driving the evolution of animals, and we see evidence of that here in the Burgess Shale as organisms began to develop both weaponry to capture one another as well as defenses.
Eyes, claws, camouflage, armor. All these new tools required coordination by a nervous system, the stuff from which the brain is made. So could intelligence be the product of an evolutionary arms race?
We certainly see on Earth a connection between predation and mobility. Organisms that can just sit in the sun and soak up the rays, they don't need to move. Their food comes to them. But organisms that prey on vegetation need to be able to move around, and organisms that prey on the preyers need to move even faster. They need to be really strong and fast. And you could argue that that dynamic of predation and motion causes the development of intelligence, and maybe somehow it leads to the sort of overwhelming intelligence that humans have expressed.
Is this the inevitable progression of evolution? From simple life via diversification and predation into intelligence? Or is an event like the Cambrian explosion so rare that life on other planets might never get the chance to pass first base.
I think that wherever we find life in the universe, that life will change through time in a way that's consistent with what we've learned about evolution on this planet. I think that is a general feature of life.
To Professor Andy Knoll, similar environmental conditions or biomes will give rise to similar evolutionary solutions, no matter where in the universe that takes place. It's a theory known as convergence.
If you look at a bat, for example, and a bird, they both fly using wings, and yet they don't have a common ancestor that flew and had wings. They have evolved that capacity from separate origins, but to a similar functional end.
In advanced animal life, some convergent biological structures are so common as to be almost universal.
Well, the eye is a terrific example of convergence because, I mean, we all understand what the eye does, that your eyes are this sophisticated sensory apparatus that allows you to gauge and engage with the world around you. Interestingly, if you look at squids and octopus, they have a visual system that is every bit as acute as ours, but evolved from a separate source. There's no common ancestor of squids and mammals that had an eye.
Is convergence a magic funnel that guides life on any planet inexorably towards intelligence? Or could there be other, more powerful forces at play?
The absence of terrestrial animals on Minerva B could indicate an extinction event, or that life has not successfully transitioned as it did on Earth from sea to land. I deploy my submarine Explorer module into the Minervan Sea. In the shelter of the ocean, life should thrive. Extensive macroalgae and porifera suggest high water oxygenation and shallow UV penetration. Ideal conditions for advanced life to evolve. A giant trilobite-like species. Tegmata body plan and dorsal exoskeleton. Comparable with late Cambrian arthropods on Earth. Complex mobility and behavior. A school swimming in formation. Perhaps a strategy to avoid predation, strength in numbers, or a kind of camouflage.
Fourth variable in the Drake equation, the fraction of life-bearing worlds that evolve intelligence, still eludes scientists today. On Earth, the great burst of life during the Cambrian explosion was an integral step on the path to intelligence. But could widespread death have been just as important?
Einstein said God doesn't play dice with the universe. Well, it seems that he does. And there's a whole lot of dice going on in the evolution of life.
Paleontologist Peter Ward is an expert on mass extinctions, the catastrophic changes of fortune in the game of life. when the majority of animals lose, and just a few inherit the Earth.
This is a mammal-like reptile, actually called a Gorgonopsian or a gorgon. It was the biggest and baddest carnivore of the late Permian 252 million years ago, and this is a baby. The big ones were 3 meters to 4 meters long, very large skulls, crossed between a lion and a big saltwater crocodile, if you will, half reptilian, half mammal, all nightmare. These guys all died out in the Permian extinction 252 million years ago. Its entire group gone.
The Permian extinction was the most devastating of the 5 mass extinction events in Earth's history. Experts believe an intense surge of volcanic activity led to dropping sea levels, acid rain, and poisoning of the atmosphere. More than 95% of marine life and over 2/3 of terrestrial animals were completely wiped out, resetting the stage for the evolution of life on our planet.
The Permian extinction did far more than just the top carnivore. It took out the herbivores, it took out most of the plants, it took out the insects, the amphibians. But what did get through were a couple of small reptilian groups, real small in size.
Like pruning a rose, cutting back the tree of life gives rise to rapid growth, as new branches reach out their leaves to the light. With little competition or threat from predators, surviving species adapt quickly to fill the gaps left behind. The tiny reptiles that survived the Permian extinction grew into hundreds of different species, including dinosaurs, who ruled the Earth for over 100 million years, until their own date with disaster arrived.
That was a very rapid and hideous death, probably every dinosaur dead within 3 to 6 months max. That was a line in the sand. Who wins? Well, who won are the small creatures. The T-Rexes die out and tiny mammals get through, and then they develop into all of the kinds of mammals we see today, and they did so really fast. The size of the skull of the animal that gave rise to us was the size of a robin egg or smaller.
Might the evolutionary branch that led to us never have grown, had it not been for the random impact of an asteroid 65 million years ago?
I would support the idea that, in fact, if we still had not had the impact, something else might be running around as intelligent, but I doubt it would be in this form and this set of behaviors that we humans have.
If our own existence is the outcome of a random cosmic disaster, then might the fraction of worlds that evolve intelligence be equally unpredictable? But if we could go looking for alien intelligence on another planet, how would we recognize it?
I think the method of looking for complex behavior on a different planet is to do what behavioral scientists do. You look, you observe, you see how animals move, how they respond to stimuli, how they act. As a biologist who does this regularly, I find that extremely exciting because the discovery quotient would be very high. But it would also be weird and alien. I sort of like weird and alien, so I think that would be a lot of fun.
Professor Roger Hanlon is an expert on the closest thing to alien intelligence on Earth. Cephalopods, squid, octopus, and cuttlefish. The undisputed masters of disguise, because they have to be.
Cephalopods are soft-bodied. All their armor was given away through evolutionary time to their cousins, the oysters and the clams, and they are soft-bodied. They're extremely vulnerable. So they have to get on by their wits. They have to do something different. making that decision in far less than 1 second. In about 1/3 of 1 second, they're assessing that visual scene. Now they're orchestrating in their skin 30 million chromatophore pigment organs in the skin that create the pattern, and iridescent reflective cells, and even the skin papillae and the bumps. There are several thousand of those. So that takes a lot of cognitive processing, a lot of brain power.
Cephalopods have the highest brain-to-body mass ratio of all invertebrates, and their brains are decentralized, meaning neural tissue is distributed throughout their body. Having split from our own group, vertebrates, well before the Cambrian explosion, they are the product of an entirely separate experiment in the evolution of intelligence.
If you look at the evolutionary history of complex behavior, we know about vertebrates and humans and primates and all the rest. But through evolutionary time, there's only one group that has branched off to produce really complex behavior, and it's these animals, the squid, octopus, and cuttlefish. So what we expect is for the white square to show up in the white head bar. The white head bar is already there. And now it's changing its pattern a little more. It's blanched a little bit. You can see these two markings down here, but we're looking for that white square to appear. And I think the correlation you might make for looking for extraterrestrial intelligence would be, don't expect anything like humans or dogs and cats and all the things we're used to. Here underwater, you have this weird